All right, Chapter 7 material. Chapter 7, the first thing we're going to be dealing with is called a population proportion. You're going to be dealing with a confidence interval and a confidence level. In the first couple of chapters, we were dealing with descriptive statistics, which means mean and standard deviation. Now we're in the inferential statistics, and where we grab sample data and we get conclusions from the sample data. Estimating a population proportion. Now, let me talk about the three different ways you're going to see proportions given or probability given in this section. And let me reiterate what we're doing in this section, because it's very easy to get confused in this section. You're basically going to be dealing with a confidence interval, a confidence level, and margin of error, I call it mode, margin of error, and finding out the sample space, the number of the sample. In other words, how big the sample needs to be, sample size. All right, these are the four things that you're going to be dealing with in these first couple of sections in Chapter 7. All right, now, Chapter 7 deals with all of these, but in 7.2, they're going to give you a probability. Now that probability is going to be in one of three delivery systems. One is going to be a proportion, meaning a ratio, 4-over ratio. Okay? The other thing it's going to be a percentage. It's going to be a percentage. And the other, it'll be a probability. In other words, a decimal. So you're going to have a fraction, a decimal, or a what? Percent. So you need to write that down somewhere, because what happens is people read the question, and even though I've taught them how to do this stuff right here, they don't understand what they're given. And that's why I tell you that in 7.2, you're going to be given a probability, and it may be given to you in three forms: a fraction, a decimal, or a percent. So you're going to have to look for that probability, and it's usually going to be in the form of p hat. That's what it's called, p hat. And when you know, we've been calling it the probability, but now it's going to be called p hat. Okay? What is a confidence interval? A confidence interval is where p is. P is between, equal to, or between this number and this number. That is a confidence interval. The confidence level is going to be 90 to 99%. That's going to be a confidence level. Margin of error is anywhere from 2 to 5 percentage points. And then the sample size N is equal to 587 people, or N is equal to 40 people, or N is equal to 12,450. In other words, how many people do you need to sample before you get a certain confidence level? All right, so here's the things you're going to be looking for. And this is what's going to be given. Now, they're going to give you some formulas, and then you just plug and chug. Now, what are you finding? Well, you'll find out here in just a minute, because the best way to do these is just by example. Golly, look what they got right there. Proportion, probability, and percent. In other words, there's the different forms that it's going to be given to you. You may get a problem that says, out of 250 people, 25 are in the Marlboro Club. All right, they have just given you a proportion. They've just given you a fraction. They've just given you a ratio, 25 over 250. Okay? Now, they may say, instead of 25 over 250, they may say 0.03 are in the Marlboro Club. Or they'll say 3% of the population is in the Marlboro Club. Fraction, decimal, percent. Okay? So the delivery is going to be one of those things. And there's your point estimate. A sample proportion, p hat, is the best point estimate of the population proportion. P hat. Why do we need a confidence interval? Well, let me just give you an example. Let's say that you are a executive you're the quality assurance executive for Southeast Michelin. Okay? Southeast Michelin. I know of two that are in the Southeast. One is in Star. Well, technically it's in Anderson, but they say it's in Star down there. And the other one is in Sandy Springs. Now, I don't know. I know there's a Crystal Palace up there around California Dreaming. There's a Crystal Palace up there. That's an office building. That must be where your office is. But Southeast Director of Quality Assurance for Michelin, are you going to be paid a lot of money? Yeah. All right. Let's say that you have a director's meeting in New York next month, and you've got to give the quality assurance for all of the facilities in the Southeast. Okay? Do you want to walk in that director's meeting with a 50% confidence interval, a 75% confidence interval, or a 95% confidence interval? A 95 or better. A confidence interval is basically telling the people that are looking at the presentation, we are sure of this. And you want to be sure, if you are an executive with Michelin, you want to be sure that you're walking into a meeting with your ducks in a row. All right? Now, in the previous slide, I put 90 to 99%. Why didn't I put 85 to 99? Why didn't I put 80 to 99? Why did I say 90 to 95%, 99% confidence level? Because if you're an executive, you don't want anything below 95% really, but 90 is good because that's the top tier. You don't want to walk into a meeting with an 85% confidence level. You don't want to walk into a meeting with a 50% confidence level. So we don't deal with anything below 90 when we're talking about a confidence interval or a confidence level. Sorry, confidence level. All right? So the confidence level is basically how sure are we in the data. Okay? All right. Confidence interval is a range, and you'll see the better application of the confidence interval and the confidence level when we're doing the problem. Okay, there we go. Now, what is a confidence level? Well, let's go ahead and explain how to use the confidence level. I tell students to make an index card. And here's your index card. And I tell them to divide it into 10 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's good enough because I'm going to go 90, 95, 91, 92, 93, 94, 95, 96, 97, 98, and the last one being 99. Why don't I do 100? Because what's the old saying? Nobody's what? Perfect. So you don't fool with 100. Why do we not go below 90? Because I don't want to walk into a meeting with less than 90% confidence level. Now, there's all kind of mathematical reasons why you don't go below 90, but I'm giving you the most practical out. You don't want to walk into a meeting with less than 90% confidence level as a director. All right, right here, we're going to put alpha. Alpha is basically 1 minus the confidence level. Okay, and it's called alpha. So, 0.01 or 1%, 2%, 3%, 4%, 5%, 6%, 7%, 8%, 9%, and 10%. And these are alphas, so you can write them 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, and 0.10. The next column is alpha divided by 2. .005, 0.011, 0.015, 0.02, 0.025, 0.03, 0.035, 0.04, 0.045, and 0.05. What do you notice about the way I wrote those? What do you notice about them? Yeah, if they're half, but what else did I do? I made them how many decimal places? So what does that mean? Area, good job. So if I'm given the area, what am I going to look for? Do it. That's called, I don't know why I did that. Z sub alpha. So I want you to look up all those z-scores. Do that right now. Get your handy dandy calculator out, inverse norm. And tell me what those z-scores are. Well, I'm going to do the first one and the last one, and then y'all can fill in the rest of them. Pull up my handy dandy. Hold on a second. Let me pull up my handy dandy. There we go. Alright, second bar's 0.0050. Negative 2.56. Is that what y'all got? Let me check it. When it put, there we go. 2.56. 2.58. Sorry. Now, I'm not putting the negative. Don't have to, because in these calculations they're positive, and it says that somewhere in the book. And I'm going to do the middle, 0.0300. I get 1.88. And 0.5. Negative 1.65, which would be 1.65. And you need to do that, and you need to keep that index card with you for your homework and your test, so you won't have to look it up every single time. I would say 90% of your questions are going to fall between a 90% confidence level and a 99% confidence level. And if it said 80, then what would alpha be? If you had an 80% confidence level, what would alpha be? 20% or 0.2. And then that would be 0.2 divided by 2 is 0.1000. And then an 80% confidence level, second function, enter. Oh, horse pucky. Hold on a minute. Thank you. 0.1000 is negative 2.34 or 2.34. So 2.34 would be, is that right? No, wait a minute, hold on. I've got something wrong because there's point. Okay, that's right. 1.1, that's right. Oh, I did? Oh, thank you. I knew something was wrong. Thank you. Okay, let me fix that. Second function. There we go. 0.1000. There we go. There, 1.28. So that'd be 1.28 right here. See what I'm saying? You could do a 70%, 70, alpha would be 30, 0.30, 0.1500. So for 70%, second function entry, 0.1500 is 1.04. See what I'm saying? But the reason I picked these top 10 is that's the ones that everybody uses. Okay, so let's move on. And that way you have your alpha over 2, and your z-score, so alpha over 2. This is what you put in the formula. Right here. Z sub alpha over 2. So that's what you're going to be using in the formula. So, and that's what they're doing right here. And I think I'm skipping a couple of pages by doing this, but we'll get to it. When we get to a problem, you will understand. Okay, here's finding the critical value right here. Find the critical value, z sub alpha, that responds to a 95% confidence level. They're wanting you to find z sub alpha over 2. So you go to your 95% confidence level, go to your handy dandy. 95% confidence level is right here, so we take our handy dandy and type in 0.0250. I just typed in that number right there. It said 95% confidence level. I typed in 0.0250 and enter. 1.96. And if you go to, there it is, Z is 1.96 right there. Golly, look what they're doing. They're adding another column. And look, Z-score. There it is. Margin of error, that's right here, but I'm not going to spend a lot of time on it because we're going to, well, I do want you to write down the formula. Here it is. And we'll do the formula here in just a minute. Just put Z sub alpha over 2. I mean, you can put Z if you want to. So you take your alpha, Z, you take your Z-score, and you multiply by PQ. Now what is P and Q? P hat is given. What is Q? Come on, remember from your past formulas, what is Q? Complement of P, Hubert. That's right, class. Y'all suck. Over N. And what is N? That's your sample. So if your sample size is 1,000 people, N would be 1,000. But we'll get to it. We'll get to it. Let's get to it. Probably going to give us a problem after this. I hope they do. If not, I'll find one. All right, here's one. It says, in the chapter problem, we noted that a Pew Research Center poll of 1,007 randomly selected U.S. adults. Well, what's N? 1,007. It just said that. It said a poll of 1,007 randomly selected U.S. adults. So that's your sample size. Your sample is 1,007 people. Showed that 85%, well, what do you think 85% is? P hat, probability, P, percentage, P hat. So what is Q hat? 15%. Says find the margin of error that corresponds to a 95% confidence level. Find the 95% confidence interval estimate based on the results, blah, 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 blah. So go ahead and do A. Find the margin of error using that formula. So I'm going to take my tool out. Where is it? All right. There we go. Now I want you to write down, let's say you don't know how to do it. Okay? Write down everything that you have. Write down, I want you to write down the list of things that you have right here. N is equal to, P hat is equal to, Q hat is equal to. Confidence level is equal to 95. Therefore, alpha is equal to what? 0.05, Hubert. That's right. So you need to look in 95% confidence level on your handy dandy index card. And when you do that, what is 95% confidence level? 1.96. So now you put not only your information given, let's see, given. N is equal to 1007. P hat is equal to 0.85. Therefore, Q hat is equal to 0.15. Now, if I have to explain this, let's just go back to chapter 2 and 3. I shouldn't have to explain that. Complement. All right? What else? 95% confidence level. 95% confidence level is equal to 1 point what? What'd I say? 1.96 east of alpha over 2. Now let's talk about margin of error. Margin of error is equal to n times the square root, not n, oh yeah, it is, p hat times q hat over what? Is that n on the bottom right here? Something's out here. What is it? N on the bottom here. All right, what's outside? Oh, z. Z. Okay. So, do we have everything we need? Yeah. So, mode is equal to 1.96 square root of 0.85 times 0.15 divided by 1,000. Or is it 1,007? Now, yes, you need to use your calculator. So, somebody, no, that's all right. I'll do it. Because y'all set me up for the wrong answer, and I'm not going to do it. I'm not going to fall for it. Mr. Bright gives me the wrong answers on purpose. All right, so that's going to be 0.85 times 0.15 equals, divide that by 1,007, and that's going to be equal to that, and then we're going to raise that to the 0.5 power. In other words, take the square root of it, and then multiply that by 1.96. I get 0.022. What do y'all get? Now, what does this mean? Well, I'm going to, just to explain to you what this means, I'm going to take this last 2 off right here. That's a 2% margin of error. So that means if I give you a graph, if I give you a poll, if I give you anything, I got a 2% margin of error. That means that my numbers can be off 2 points either way. It's not a very big margin of error. Okay? Now, what's coming up in 2016 if it ever gets here? Yes. Why am I bringing up the election with margin of error? Because you're going to see poll after poll after poll after poll. And what if you see a poll that says 51% votes for Hillary Clinton and 50% vote for Donald Trump, and there is a 2% margin of error? Then that poll is what? It's tied. Why? Because it's within, what's the difference between 51 and 50? 1. It's within the margin of error, it's 2%. So technically they're at a tie. All right, mathematically they're at a tie. What if you had 54% for Hillary Clinton and 50% for Donald Trump? Then you would have something to say, okay, well, it looks like Hillary Clinton's going to win this state because it's beyond the margin of error. 4 points. See what I'm saying? So it's very important that you understand what margin of error is, especially coming up if 2016 ever gets here, and I don't think it ever is. You ever been waiting on something and it just never gets here? I don't think 2016 is ever going to get here. Anyway, so, but that's what that means. But in this case, it's 2.2 what? Percent. Okay, that's just, I was showing you the 2% just to give you something, but in our problem it's 2.2%. So, P hat is going to be between 82.8%. Somebody check me. 82.8% and 87.2%. That's your confidence interval. What did I do? Well, I took the 2.2% and I subtracted it from 85, or 85%, and I got what? That should be right. Somebody check, what's 82.8 plus 2.2? Isn't that 85? All right. And then what I do on the right side? I add it, just like your standard deviation, remember? You subtract it on one side, and add it on the other. So there is your confidence what? Interval. That means that my P is going to come up between 83% and 87%. And that's based on a 95% confidence level. So if my P comes up to be 0.5, then I know I've got a 95% confidence level to say that number ain't right. All right, I've done A and B. Based on the results, can we safely conclude that more than 75% of the adults, yes, they know. 75%, we know there's more than that. Assuming that you are a newspaper reporter, write a brief statement that accurately describes the results and conclusions of the relevant information. We just did that. We just talked about it. We just said that based on the 95% confidence level, we have a confidence interval of 83% to 87% know what Twitter is. So 75 is a bunch of bullcrap. Of course, you wouldn't do it that way because you might offend somebody, because we're in a very political correct society. So let's see what they got. Let's see if we know what we're talking about. Okay. Let's go to the next page, see if they know what we're doing. Here we go. What did they get for margin of error? 0.022. And what did they get? 83% to 87%. That's what we got. Based on the confidence interval, it does appear that more than 75% because of the limit, so therefore 75% is not right. That's basically what C means. And statement says the same thing here. Well, the reason it's rounded to 3 significant figures is right here. Right there.
So we should use significant.
Well, just, I would at least, in a general rule for statistics, I'd at least take it to the 100th. Okay? But I'm not going to mark it off if you put 2.21% as a margin of error. I wouldn't mark it wrong. Okay? So we're going to do a bunch of these, because that's a lot of these I put on the test. And this test is only going to cover 7.2 and 7.3 probably. Unless y'all want me to put 8 and 10 on there. I'll do that just because, try to get you to fail. All right, I want you to make a note right here. Here is how you find the sample size, right here. Now I want you to look at these two. Let me just blow them up for you. No, let me just. Now, you don't have to write down both of them. Just write down one of them, and that's the top one. Because I'm going to explain how they get this one. And then you'll say, oh, okay, I'll just remember one of them. So go ahead and write down both of them if you want to, but circle the top one. I'm sorry, Hillary Clinton just said, this is an important step in putting the lid on Iran's nuclear program. They really think that Iran is going to stick with the nuclear policy that they have. No comment.
Ireland the last country, or the only country to run under Sharia law? Or,
No, it's not the only country.
okay.
Saudi Arabia still does Sharia law. But that's the best way to go. Like I said, no comment. All right. Now, what's the difference between the two? Well, the difference is P is not known. Well, if P is not known, then what's the probability of something coming out yes or no? 50-50. So if you plug in 0.5 and 0.5 for P and Q, what do you come up with? 0.25. So you can just remember the first one. You can just remember this formula and just remember if P is not in the problem, you say, okay, I'm going to assume that P is 0.5. And if you assume that P is 0.5, then what is Q? 0.5, then 0.25. So you can remember 2 or you can remember 1. I say let's remember 1. And then just have that note in the back of our head that if I don't see a P, then I got to use 0.5. Okay? And here's your round off rule right here with N. Because you're trying to find a sample space or a sample size. It says if the computed number is not a whole number, round the value what? Up. Okay, now we're going to go over this a few times because some people, y'all can't read. And what I mean, y'all can read the sentence. But this is what y'all say. If the computed sample size n is not a whole number, round the value of n up to the next larger whole number. Hubert, what does that mean? That's what y'all do. Not y'all 5 in here, but students. That's what y'all do. Y'all read it and go, what does that mean? If the computed number is not a whole number, define not a whole number. A decimal. Okay, let's go back. Let's put it back in. If the computed sample, if the computed number is a decimal, then what do you do? There we go. Oh, well, what if it's a whole number? Leave it alone. Okay? That's like these handouts. People read them, but they They don't retain anything. They read them, but as far as the test, this final exam going to be online, did not respond. Okay, next page. All right, let's look at this one. What percentage of adults buy clothing online? Blah, 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 are just a few of the many companies, blah, 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 blah. How many adults must be surveyed? How many adults must be surveyed? What are we looking for? In. How many adults must be surveyed in order to be a 95% confidence level that the sample percentage is in error by no more than what? 3%. 3 percentage points, 3%. MOE is 3%. Everybody got that? 3%? Use this recent result from the Census Bureau, 66% of adults buying clothing online. Then that means 66 is probably your Pete's hat. All right, I'm going to let y'all work it. You got the formula. You just wrote down the formula. You've got a P, so that means you got to find Q. Oh my gosh. I shared a post. And like 2 people have been ranting and raving and arguing with each other on my post for like the last 3 days. And I'm like, good gosh. Yeah. It's Bush's fault. All right. It says blah, 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 and we're going to take our, let's see, 95% confidence level and 66. All right, there's our formula. Now, the good thing about our index card is we don't have to look up anything, do we? Because our index card tells us that a 95% confidence level is what z-score? 1 point what? So, n is equal to 1.96 squared times 0.66 times 0.34 over 3 squared. Crank out that math. And I'm going to do that. So that's going to be 1.96 squared times 0.66 times 0.34. That's supposed to be 0.03, is it not? Is it 3 percentage points? So that's 0.03. Sorry. 0.03. So divided by parentheses 0.03 squared, close parentheses. I get 957.83, and that's what I'm going to put down for my answer, right? No, I'm going to put 950 what? 8. 958. Now, if it tells me to round to the nearest thousand, then I'll 958. I'm transposing numbers up here. 958. Now, why did I say 958? Because the rule that we just read out said that if you get a decimal, doesn't say how big a decimal, it just says a decimal. If you get a decimal, you round up. So that's what now. If it says round, if the directions say round up to the nearest thousand, then it'd be 1,000. But in this case, 958. Look there. 958. Assume that we have no prior information. Okay? So let's assume that we have no prior information. Do we change the formula? No. We just take out this number and put what? 0.5 and 0.5. Crank that out. So that's going to be 1.96 raised to the second power times 0.5 times 0.5 divided by parentheses 0.03 squared, and that's going to give me 1,067. 1,068. Are we talking about detriment to the survival of the species of the human race on the face of the earth, 960 versus 1,068? No, we're not. Okay, so it's not going to make that big of a deal. Which one would you go with? If you were a executive for blah, 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 and you had a report due next Monday, which one would you go with, 958 or 1,068? 1,068. You go with more. Why you want to go with more? Big number rule. Remember the large number rule. Chapter what? 1 or 2? The large number rule. The more trials, the closer you're going to get to the actual probability. Okay? Now what I'm saying is, the answer is 958, okay? But what I'm telling you is, between the two numbers, this is A and this is B. I'm talking about in a real world situation, would you go with the 960 or would you go with the 1068? You'd go with the 1068 if you were going to do if you're going to take the time and the money to survey 958 people, and just if the probability is off by 1500ths, which is the difference between 66 and 50%, 1600ths, all right? If you're going to change it just a little bit and get 1068, which one you think would be better for your report? 1068. Now, do you have to use 1068? No. To get the 95% confidence level, you have to use at least 958. But added insurance would be to use the 1068. That'd probably bump you up to maybe a 96% confidence level instead of a 95% confidence level. Just to kind of, it's kind of like this. If you know that your car leaks a little bit of OIL, okay? And you know that because when you park in your garage, you've got a little put of OIL on the garage floor. When you change your OIL and put a new filter on, do you put in 4 quarts or do you put in 4 quarts and maybe a little bit more than 4 quarts? You put in a little bit more than 4 quarts because you know your car leaks OIL. All right? Now, do you put in 16 quarts? No, because it won't hold it. But you might put in 4 quarts and maybe a quarter of a quart or a half a quart. That way it'll stay at full level longer despite your leak. It's kind of like that. Okay? You know that to get a 95% confidence level, you do 958. But even if this is 0.5 and 0.5, that bumps it up to 1068. That's the 4.5 quarts. That just gives you a little bit more. Okay, let's do a nerd. Let's go to your homework on 7.2. Because basically we've covered the formulas you need to know for this homework. Some of them are pretty simple. I'm not going to go over the ones that are real simple, but I'll just voice how to do it. Okay, they want to find the z-score that corresponds with alpha equals 0.07. Well, that's a 93% confidence level. Look there, you already done it. Golly, you're amazing. What is it? 1.81. Now, did she do that because she's Rain Man, or did she have it on her index card? She's done it on her index card. It's a 93% confidence level. 93% means alpha is equal to 7 cents, or 7%. So those are easy. I'll give you 3 or 4 of those on the test, even though some people still get them wrong. Okay. A research institute poll asked respondents if they felt vulnerable to identity theft. In the poll, N is equal to this, X is equal to 600, who say yes, use a 99% confidence level. All right. Okay, here is where people get confused. Because they didn't give you a P. Yeah, they did. Where is the P or P hat? Where is it? It's not 99. That's your confidence level. Okay, you're not supposed to not know. You're supposed to know. I'm just telling you that. You're not helping me out here. How did I tell you that P hat was going to be given to you? 3 different ways. A percent, a decimal, a fraction. Fraction, decimal, or percent. Do we have a percent? No. Do we have a decimal? No. Then you got to find the what? Fraction. And what would be the fraction? Okay, let's flip that around. 600 over 1,090. Here's poor old Horatio. Here is where they give you the numbers, but all of you did exactly what I told you you'd do. Patrick Starfish. You froze when you said there wasn't a percentage, there wasn't a decimal, and y'all sat there and went, X? I think you said X. X. You have to put X over N. That's called a proportion. It's called a fraction. It's called a ratio. Poor old Horatio. So now, you do this. Instead of putting your P up there, you say, okay, P hat is equal to blah, blah, blah. P hat is equal to 600 divided by 1090. Which is equal to 0.6. Therefore, P Q hat is equal to 0.4. Now somebody fix it for me. What is your P hat? How much? 0.55. That's what you need to use because I just did it in my head. And then that would be 0.45. Okay, so these are what you use. Okay, what else we need? Well, 99% confidence level, Miss Rainman. What is 99% confidence level, Miss Joshi? 99%. 2.58. So Z sub alpha over 2 is equal to 2.58. Is that what you said? Okay. We're done. Let's use our, what are they asking for? Okay, they want the best point estimate. They want your critical value. So, they don't want the margin of error? I guess not.
A through D's.
Yeah, B's gonna be margin of error.
Oh, so we done, okay, so 2.58 goes here, right? I don't know what they're asking for. The critical value is 2.58. I'll just type in 3. I don't know. I've just had a brain bubble. Y'all ever have brain bubbles before? Yeah, that's this. I'm sorry. I kind of got down the gun a little bit. Now the margin of error. Now what is the margin of error? Well, Mo is equal to, or Z-score, multiplied by P hat, Q hat, over N. So that's going to be MOE is equal to 2.58 times the square root of 0.55 times 0.45 all over, I have no idea, 1,000 something, 1090. And somebody crank all that out. Just 2 decimal places, since these are 2 decimal places, let's do 2 decimal places. So 0.55 is that.
Yeah,
0.0388. All right. Okay, 89. Somebody else check, make sure we got the same numbers. 0.0389. I'll check it on my calculator. All right, 0.55 times 0.45 and divide that by 1090 and raise that to the 0.5 power. I get that multiplied by 2.58. .0389. Y'all got that? So our margin of error is 3.9. Margin of error is 3.9. Coach, move it one. Whatever, work with me, please. 3.88. Or 3.9, depending on what they want, is our mode. So if you wanted to find your interval, then what is our interval? Somebody is 0.6, 0.55. That's 55%, right? Right? So 55% minus 4% is 51%. So 51 to, what's 55 plus 4%? 59? Okay, somebody do the decimals, and that's going to give you your interval note, your confidence interval. So, okay, that's the right answer. Okay. I don't know what they want, but okay, margin of error, it says round to 4 decimal places. So 0.0389. 0.0389. And then they're probably going to ask for the confidence interval. What'd you get?
51.11.
0.511. And what's the other one?
58.8.
And that's your confidence interval. Write a statement, whatever, that correctly interprets the confidence interval. All right. Now, they said in a poll 60%, and we got, our confidence interval was, where's our confidence interval? 51 to 59%. It looks like ours is a little bit low. In other words, we're saying we got a 99% confidence interval that the numbers should be 51 to 58, 59%. And ours comes out to 0.55. So ours is within the confidence level. I'm looking. I would say B. I doubt it would be correct, but then that means it's C. Oh, it says 99% of sample proportions will fall between lower bound and upper bound. Well, they do. They fall between the upper bound and lower bound, but my problem is I don't know what's better. 99%, there is 99%, or one has 99%. I don't know. See. One has 99%. So let's go with one. So remember when you do this question on test or homework, dang on one. One has 99% confidence level. The reason I didn't pick D is because it's equal to the population proportion. That's not right. It's between the upper bound and the lower bound. And that's why I picked this one to begin with. All right, you try this one. This is another example of not being a decimal or a percentage. And all I care about is the main. I don't care about all that asking questions and stuff. I just want you to be able to tell me the margin of error and the confidence interval, because those two things go kind of hand in hand.
Is that thunder? I hope it is. I hope it rains all day.
Something like that.
Good. I want it to rain. I got some hay fields that need it.
Okay, so this is the same type problem. And Z sub alpha over 2 for 95% or 90% confidence level is equal to what? 1.65. Everybody got that? And then P hat is equal to 919 over 2608, which is equal to give me 2 or make it 4.
3, 5, 2, 4.
So therefore, Q hat is equal to 0.6476, right? And of course, they want to know, point estimate is 0.3524. And they're wanting to know what your sample size is going to be, your interval. So margin of error is equal to, and now we're going to take our z-score at 1.65 and multiply that by 0.3524, 3524 times 0.6476 and divide that by 2608.
So, take off 0.3524, multiply by 0.6476, divide by 2608, raise that to the 0.5 power, and multiply that by 1.65. 0.0154. So that's 1.5%. So your margin of error is equal to 0.0154. So if we take that off of 1.5%, so your interval is, let's see, the 35%, that'd be 36.50. And I'm off because I didn't do that last percentage point, so I'm going to be off there. And then 35 minus 1.5 would be 33.335. 0. Now I'm off by that. That last digit is going to be wrong. But we can check the others. Let's see, 0.3524. Okay, I must be wrong there. Huh? Oh, they just want 3. Okay, that's fine. I wouldn't mark that wrong if you did that on test. All right, margin of error is 0.015 or 0.0154. .0154. Can't hardly see up here, it's so dark. And I'm just going to put a 3 here and a 3 here because I know mine are off by the last digit probably. .337, yeah, mine's off. 0.335 and 0.368, yeah, I'm off a little bit. That's because I just didn't do that last digit, that 4, I didn't add that in. Okay, let's see if we can figure out what they're wanting. All right, what did we say P was? 35%. All right, 35% falls in this. So you would say B. Didn't we say 1 has? Okay, and you know it's not equal unless it is equal, and then it would be. So we'll say it's B. Darn. Hallelujah, it's raining. Answer. All right, now, well, what's the difference? What's the challenge? Well, the challenge is to make sure you know when to do what. All right, what do they give you in this one? Poor old ratio, percentage, or decimal? Percentage. So what is Q? Well, P is 0.63. What is Q? 0.37? Yes, class, that's right. All right, let's do another one. I don't do that one. Let's see. Here's one. What about this one? .50.6. So that's going to be 0.5060. So let's do this one. It says in a poll, blah, 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 50.6% said that body piercing and tattoos were big, grooming red flags. Among blah, 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 how many of them said that body piercings and tattoos were? Well, A is real simple. You take 561 and multiply it by what? 50.6 or 0.5060. So that's how you do A. That's not too difficult. So take your handy dandy calculator and take 561 multiplied by 0.5060. I got 284. Is that what y'all got? It's a miracle. Now you can do the stuff that's elementary math. Now you can do the math you're supposed to be doing. I want a confidence interval with a 99% confidence level. And if you can't do it, then consider yourself what? A failure. I think failure's so much better. It has more of a kick to it, especially in the stomach.
Priority 1 message coming in. Priority 1 message coming in on secured channel.
All right. %. What is that? 2.58? All right, so we got margin of error is equal to 2.58 times the square root. What did we say? Okay, 0.5060, 0.5060 times 0.493 or 0.940, sorry, over n, which is 561. All right, somebody do that and give me 4 decimal places. Okay, what?
5.5%. So margin of error is equal to 5.5%. Now, I'm gonna use 5.5, I'm not gonna use that. Now, y'all use this in your homework, but I'm gonna use this for my up here, because I'm not gonna try to do that in my head. So, we got a 50.6, that's 51%. So, 51%, so that'd be 56.5. And 51% minus this would be 46.5 or 40, something like that. 46, let's see, what was it? 51% minus 5, yeah, 46.5. Somebody check me. I think that's about right. Somebody give me the decimals. What is 0.5060 minus that? 15, 4, 5, 15. Y'all check me. And then 5505 or 5605. Is that right? Okay. So that's your, this is what your actual answer should be. Something like that. .45.4515. Okay, I'm sorry. 4525. Oh, 3. Okay, and .561. Okay, now they say do use 80%. So 80. Didn't we do 80% on that card? Yeah. 80% is .1000. What was that one? What's .1000? What's the, I want to say 1.28, but I may be wrong. Somebody do an inverse norm of 1,000, .1000. Okay. So it was 1.28. So for the second part, you'd use 1.28. So for part B, use 1.28 times the square root of PQ over N, and that'll give you a margin of error there. Which we can do that. Let's see. Let me get my handy dandy calculator back up here. There we go. And we're going to take our 0.5060 times 0.4940 equals divided by dang old 561, and raise that to the 0.5 power. I get 0.0211 multiplied by 1.28, 0.027. We'll just do this right quick. We'll just add that. Stow, where you get your bread, and we're going to alpha error. Okay. All right. Now we're going to take our 0.0560, 0.5060, add alpha E, and then take 0.5060, subtract alpha E. And that should be your interval. So
.533. And .479. I must have done something wrong. Did I not get the same thing?
You had it backwards.
Did I type it? Oh, I'm typed it in. I'm sorry. I typed it in backwards. Okay. I wouldn't mark that wrong. I would say, what's wrong with you, or you're on drugs, so evidently I'm on drugs or something. I don't know. I don't know why I would put .533 first. Oh, well. Oh, I know why, because I did it on calculator first. That's why. Okay. I'm sorry. All right, now it says, let's get the answer wrong on this question. Compare the confidence intervals from part B and C. Okay, 45% to 56% and 48% to 53%, right? So it's a shift. Let's see, it comes down. I'm thinking out loud. It comes down 3% here. And what does it do here? Goes up 2%. See? Really 3%. Down 3% here and up 3% here. Does everybody see that? Or am I crazy? 53 to 56. It went down. 45 went up 3. So compare the confidence levels and identify the interval that is wider. 48 to 53. I believe they're both the same. Let me check something here. When in doubt, always pull out the calculator. 0.452. No. 0.561 minus 0.452. And then 0.533 minus 0.479. Okay. So the top one is bigger. Everybody see that? You have to do that because you can't, you gotta look at it because one drops. You see how this one drops 3% and this one adds 3%? You see that? So it's kind of hard to tell which one's wider unless you do it in the calculator. So, all right, we agree that this one is wider, so I don't know how to. The 99, what's the first one? 99%? Okay, the 99% is bigger than the 80% confidence level. I have no idea. I'm not going to read all that either. So I'm just going to pick one and put the 99 is wider than the 80%. We spend another class on why. See? I did it right. I can't believe it. It says the 99% confidence interval is wider than the 80% confidence level. As the confidence interval widens, the probability that the confidence interval actually does contain the population parameter increases. Duh. First two is all I care about. Everybody with me? Let's see, but let's do one of the ends. Because they're going to ask you, that's going to be a couple of questions on the test. Here we go. Use the given data to find the minimum sample size required. Margin of error 6.06. Confidence interval 95%. P and Q are unknown. So, margin of error, MOE, is 0.06. P is 0.5. Q is 0.5. And what's our Z-score at 95%? I'm sorry, what? 1.96, so you're good to go. So, that dang old margin of error goes on the bottom, 0.06 squared. If I remember my formula. And then we take that 1.96, and don't we multiply it by P and Q? I can't remember the formula. So, 1.96 squared times 0.25 so 1.96 squared times 0.25 divided by parentheses 0.06 squared, close parentheses. I get 267. What do y'all get? We got 267 too, class. Hubert, that's good, class. Thanks for the interaction. All right, try that one. They try to trick you here. Margin of error is 6 percentage points. Instead of putting 0.06, they put 6 percentage points to see if you'll fall for it. What goes with the 90% confidence level? What's the Z-score? 1.65. Our P hat is equal to 0.34. So our Q hat is equal to 0.6 what? And margin of error is 0.06. So that's 1.65 quantity squared times 0.34 times 0.66 divided by 0.06 raised to the second power. I got 170. Is that what y'all got? So, as a recap, what do you need to do to be successful in 7.2? Well, one, you should know you should have an index card from 90% to what? 99%, showing the confidence intervals, the confidence level, alpha divided by 2, and then your z-score at alpha divided by 2. 2, you should know your formulas. The first one is the margin of error, and that's equal to, I'm thinking, PQ over, I done lost it. I know N, we just did N. N is equal to your z-score squared times p hat, q hat, over margin of error squared. Okay, this is the square root. P hat, q hat, over n, multiplied by z. Okay, there's your two formulas that you need to know. What else do we need to know? The biggest thing we need to know, we should have put it as number one, is that p hat is going to be given to you in three different forms. And what are those forms? For-over ratio, a fraction, a decimal, or a percent. And that's all you need to know for 7.2. 7.3, we're going to do something a little bit different. But we're not talking about reinventing the wheel here. We're talking about reading the question. We're talking about finding out and do that index card. If you do that index card, then you don't have to worry about number one anymore. All you got to be able to do is these two. Actually, this should be number two. But, yeah, let's change that to number two. This is number two, and this is number three. Because you got to know this. And usually when I say a fraction, hold on a second. When I say a fraction, I mean a sample of 500 people were asked if their life sucked. 200 said yes. Okay? That's a fraction. What is the fraction? 200 over what? 500. Okay, so that's one way. Okay, here, p hat is equal to 200 over 500, which you don't need a calculator, because that's 2 over 5, which is what? 4/10. 5 will go into 10, 2 times 2 times 2 is 4. So therefore, q hat is equal to 300 over 500, or the complement of 0.4 is point what? So that is how a fraction is given. And of course, a decimal, they would say the probability of people hating their life is 0.3, right? And then this one would say 30% people hate life. See what I'm saying? And see, that's where people get, they don't, and they've got this to the side, but then when they get here, they go, well, what, I don't understand. Well, that's why you need to know the three delivery systems. And then after you get this, then all you do is decide what? Which one to use. We good? And y'all feel good about yourself, right?